We started modulus inequalities yesterday. We were done with the process, the method for solving equations that involve the modulus function. Equations को हम कैसे solve करते थे? Equations के लिए हमने क्या कहा था कि modulus remove करके बस एक side पे plus minus लगा देना और उसको solve कर लेना. ठीक है? It doesn't matter if you have modulus on both sides or you have modulus on one side. All you have to do is just remove the modulus sign and put plus minus. किसी भी एक साइड पे plus minus लगा देंगे, दो equations बनेगी, उनको solve कर लेंगे. ठीक है? लेकिन you have to be a bit careful here. Sometimes what happens is you end up getting some extra answers. So whenever you are solving equations involving the modulus function, you always have to verify your answers at the end. That is going to be important. So for example, we did this particular question and this. You were getting two answers. One was x equals -8 and the other was x equals -2/3. Now, when we verified these answers, it turned out that -8 did not satisfy the equation and -2/3 did. So the only correct answer would be -2/3. Okay, so you'll have to ignore -8 here. That's going to be important. So whenever you are solving equations, or we'll see inequalities, you always have to verify your answers at the end. You have to input those values back in the equation to check whether they satisfy the equation or not. All right, that is going to be important. So that's what we started from yesterday. We did equations, and then we started discussing modulus inequalities. So we started with some simple examples like what happens if you have modulus of x less than 5. We could actually do this mentally. Modulus of x less than 5, that basically means x is between -5 and +5, right? So we discussed the logic for this. But from the exam perspective, we're going to have inequalities that look like this. You'll have x terms on both sides of the inequality. Sometimes you'll have modulus on one side, and we'll see examples today. You can also have modulus on both sides of the inequality, right? Now, what is the process for solving such inequalities? We discussed this process yesterday. I'll quickly review that again. So how do we start? What's the first thing that you do? The first thing you do is you say, treat it as an equation. Treat this inequality as an equation. So whatever is the sign that you have in the middle, replace that with an equality sign. Equation se replace kar de usko. All right. And then you just follow the process that we have learned for solving equations involving the modulus sign. So what you do is you put plus minus on any one of the two sides and remove the modulus sign, right? So that's what we do. When we do that, we get two equations. And from those two equations, we get two values for x. That's what we're getting here. We got two values of x. So that's the first thing that you've got to do. So if it's a 4-mark question, for instance, finding these two values, that earns you 2 marks generally. Okay, if it's a 3-mark question, in that case as well, generally it earns you 2 marks. Okay, the other 1 mark or 2 marks are going to be to figure out which regions around these 2 points are correct. Okay, how do you do that? Once you have figured out these cutoff points, what you do is you draw a number line. You draw a number line, you mark those points there. -8 is a smaller number, so that's going to be on the left side here. -4/3 is a bigger number, that's a larger number, that's on the right side. And now what you do is you see on the number line, your number line is divided into 3 different regions. One region is towards the left of -8. One is in the middle of these two values, between -8 and -4/3, and the other region is towards the right. All you have to do now is you have to take one number in each of these 3 regions and check if it satisfies the original inequality or not. If it satisfies, that means that region is correct. If it does not satisfy, it means that region is incorrect. And then based on that, you can write down your final answer. Okay. Now, this is a method that works for every kind of modulus inequality that you have in your syllabus, right? So this will work every time. So this is one standard process that you can use for all modulus inequalities. If you know this, these are easy 3-4 marks on your P3 paper. Okay. Any problem with this? Any questions? Now today we want to do some more examples on this, and hopefully if we have enough time at the end, we will also discuss graphs of the modulus function, right? So that's going to take some time as well. We'll quickly do that towards the end, hopefully if you have enough time. Otherwise, that will be for tomorrow. But let's see. Any questions on this?
सर मुझे सर आपने कल करवाया था जिसमें दोनों आंसर्स गलत आ रहे थे, उसका आपने बताया नहीं था कि वो कैसे करते हैं सॉल्व मॉडुलस में।
वो तो मैंने खुद से एग्जांपल बनाई थी, उसमें उसका सॉल्यूशन था ही नहीं. So when you're getting both incorrect answers, it doesn't have any solution. इसका कोई आंसर है ही नहीं, इसका कोई भी आंसर नहीं है. तो आपको कैसे पता चलेगा? जब आप वेरीफाई करेंगे तो आपको पता चल जाएगा कि आंसर्स नहीं है.
सही है सर, ओके
राइट. लेकिन ये दिस इज जस्ट फॉर योर ओन अंडरस्टैंडिंग. कैम्ब्रिज में इस तरह के क्वेश्चंस आते नहीं है कि कोई भी आंसर ना हो. राइट. सो फ्रॉम एग्जाम पर्सपेक्टिव यू डोंट गेट समथिंग लाइक दिस, बट यू डू गेट समथिंग लाइक दिस जहां पे एक आंसर हो सकता है सही हो, दूसरा गलत हो, तो आपको वेरीफाई करना पड़ता है. ठीक है, वेरीफाई करना जरूरी होता है. ऑलराइट, okay, let's go back there. Now today we want to do some practice questions from this worksheet that I posted. All right, so let's start with this. This is question number 2 from the worksheet that I posted. Let's start with this. Okay. So we have to follow that same process that we've learned. How do we start? This is an inequality that we need to solve. 2x is greater than modulus of x minus 1. So what's the first step? The first thing we do is we treat this as an equation. We say, let's say this is 2x equals modulus of x minus 1. We have to solve this inequality eventually, but for a moment, we treat this as an equation because that's going to give us the points of intersection of this graph and this graph. And once we have that, once we have those cutoff points, then we can use the number line to figure out which regions are correct. Now let's try this. We wrote this as an equation first. That's the first thing we do. And now what we do is we put plus minus after removing the modulus sign. So modulus sign remove karke, you put plus minus like this. From this you get two equations. One is equals x minus 1. And the other is 2x equals minus into x minus 1. Now you simplify this. From the first equation, you get 2x equals x minus 1, and that gives you x equals minus 1. And from the other equation, you're getting 2x equals minus x plus 1, which gives you 3x equals 1 and x equals 1 over 3. These are the two cutoff points that we were looking for. Okay. Once we have found these 2 points, what we do is we draw a number line. We draw a number line like this. We mark those points here. One is minus 1 and the other is 1 over 3. And now we take one number in each of the 3 regions that we are getting on the number line. So one region is on the left here, one is in the middle, and one is towards the right side. We take one number in each of these 3 regions. Now, what could be a number less than minus 1? We could try minus 2. Any number between minus 1 and 1 over 3, an easy number to work with would be 0. And let's take a number on the right side. 1 over 3 is a bada koi number. We could take 1, for instance. Okay, so we have taken one number in each of these 3 regions. Now, what was the inequality? Let's write that inequality here. 2x greater than modulus of x minus 1. This was our inequality. Now we have to check which of these 3 numbers satisfy this inequality. Okay. Now, how does that happen? Let's input minus 2 first. Minus 2 input karte hain. 2 into minus 2, that's greater than modulus of minus 2 minus 1. All right. Now let's simplify this. This gives us minus 4 greater than minus 3 modulus. And that is minus 4 greater than 3. Is that correct? That's obviously incorrect. This is negative, this is positive. So this inequality is incorrect. This region does not satisfy the inequality. Okay, let's try the number in the middle. 0 try karte hain. 2 into 0 greater than modulus of 0 minus 1. So we have 0 greater than -1 modulus, which is 0 greater than 1. This is also incorrect. Let's try 1. Let's input 1. That gives us 2 into 1. That's greater than modulus of 1 minus 1. And we're getting 2 greater than 0 here. This is correct. So this region is correct. How do we write down our final answer now? We say anything that's towards the right of 1/3 is correct. The right side wala region hai, this is correct. Okay. So what's our final answer then? We say this is x greater than 1/3. This is our final answer. Okay, let's try something slightly more complicated. Let's try question number 1 from the worksheet. Now this has some constant a as well. Let's see what happens when we get something like this. Okay, this is question number 1 from the worksheet. Okay, now it says, given that a is a constant, solve this inequality. So now we've got an inequality that is in terms of a. So our answers are also going to be in terms of a. That's the only difference that's here. Otherwise, the concept is exactly the same. The method that you're going to follow is going to remain unchanged. Okay. Again, how do we start? The first step is you say, let's treat this as an equation. So you've got x minus 3a modulus that equals modulus of x minus a. Okay. Now you have to remove the modulus sign. You can remove the modulus signs and put plus minus on any one of the two sides. It doesn't matter which side you put this on. किसी भी side पे डाल दो. X minus 3a. Let's say that equals plus minus x minus a. Okay. Now we get two equations from this. X minus 3a equals x minus a, or x minus 3a equals minus x plus a. Okay, दो equations आ गई. ऐसे दो values of x आएंगी, number line आएगी. उस number line से आप regions देखेंगे क्या आते हैं. Okay, take 2 minutes and try this. There's a Zan going on here. I'll take a 1 minute break or a 2 minute break. उतनी देर में आप ये try करें and tell me what answers you're getting from this. Okay, try this yourselves and see what you get. Let's solve these two equations and see what we get from this. So from the first equation, what do we get? Everything just gets cancelled. X and x get cancelled, right? So we have x minus x, that equals 3a minus a, and that's 0 equals 2a. From this, you get a equal to 0, which is not possible because it says in the question that a is a positive constant, so a cannot be 0. So from this first equation, we're actually not getting anything. Okay, this doesn't give us anything. That's all right. Let's look at the second equation. From the second equation, we get x minus 3a equals minus x plus a. Take x to the left side, that gives us 2x. On the right side, we've got 3a plus a, which is 4a, and x equals 2a. Now, in this case, we have only one cutoff point. Okay, in this case, we have only one cutoff point. So when you draw a number line to check which regions are correct, you will have only one point on that number line, which is 2 times a. Now, this point divides your number line into two regions now. There's one region towards the left of this point, and there's another region towards the right of this point. And what you do now is you take 1 point on either side. Take 1 point to the left of this and 1 point to the right of this, and check whether it satisfies the inequality or not. What is the inequality? The inequality is x minus 3a modulus. That's greater than modulus of x minus a. This is what the inequality is. Now, let's take 1 point to the left of it and 1 point to the right of it. What could we take? 2a से कम छोटा number हम क्या ले सकते हैं? Could I just take 1 here? Will that work? Anyone? Can I take 1 here? Should that be okay?
No, sir.
No? Why not?
So वो variable के terms में तो variable ही लेंगे.
Okay. So we have 2a here. Put whatever numbers we take here on the right or on the left, they have to be in terms of a. Why? Because otherwise we could have a problem. If we use 1 here, for instance, what if the value of a was 0.2? What would happen? If a was 0.2, this number would actually become 0.4. And 0.4 is going to be smaller than 1. So 1 would actually turn out to be towards the right side in that case. Okay, so that would be a problem. So we can't take a number without the letter A. We have to take something that is in terms of A. Similarly, we have the same problem. If we take, let's say, 5 here, what if the value of A was, I don't know, 10? Then this number would have been 20. 5 left पे आ जाता फिर और right पे नहीं आता. So you can't take a number like that without the letter A. So if you want to take something on the left side, one idea could have been that you take A. A means 1 times A, right? And take one number to the right. Again, in terms of A, you could take 3A, 4A, 5A, whatever you want. Let's say I take 3A on the right side. Okay, I'm taking these two numbers. Now we've got to verify both of them and see which of them satisfies. X minus 3A, in place of X, we put A here. A minus 3A modulus, that's greater than modulus of A minus A. This gives us minus 2A modulus, that's greater than 0. And 2A is greater than 0. Is that correct? That is correct because A is a positive number. If A is a positive number, 2 times A is also something positive. So 2A greater than 0, that is correct. Now let's try 3A. Gives us 3A minus 3A on the left side. When we put X equal to 3A, X की जगह पे जब 3A डालेंगे, तो ये आ जाएगा. On the right side, we've got modulus of 3A minus A, and this gives us 0 greater than 2A, and that is incorrect. So the region on the left side is correct. The region on the right side is not correct. So our final answer therefore is X less than 2 times A. This is our final answer. Make sense? Any questions on this?
Sir,
Yes.
is it possible कि दोनों side satisfy हो रही हो?
It is possible, but again, that would mean X could be anything, right? That is possible. But theoretically, that's possible, but you don't get questions like that in the Cambridge exams, because you can't write down an answer then, because X would be any value in that case, right? So for instance, if we have an inequality like this, modulus of X greater than minus 2, just as an assumption, if you had an inequality like this, now this is an inequality that is always true. अब इसको सॉल्व करने की कोशिश करेंगे, कट ऑफ पॉइंट्स आते भी हैं आपके, अब मेकिंग नंबर लाइन के ऊपर हर पॉइंट सेटिस्फाई कर रहा होगा, बिकॉज मॉडुलस ऑफ एनीथिंग इज ऑलवेज गोइंग टू बी पॉजिटिव, या मिनिमम 0 हो सकता है, एंड दैट्स ऑलवेज गोइंग टू बी ग्रेटर देन -2. तो इस तरह की इनइक्वालिटीज के सारे सॉल्यूशंस आते हैं, बट अगेन you don't get such inequalities in the Cambridge exams, at least. So you won't get in that case in the exam. All right?
Yes, sir.
Okay, good. Now let's try another one. And after that, we will discuss graphs. I think we can probably do that quickly. Iske alawa, if you have any other questions, you can also discuss that from the worksheet. Actually, there are some of them which you are not supposed to worry about for now. For instance, this question number 18, this involves logarithms. You can skip this for now. ये आपको attempt नहीं करना. 18 आपको छोड़ देना है. ठीक है? So don't worry about that. We haven't covered that yet. वो एक और topic में आएगा. Apart from that, you can do, so apart from that, question number 3 as well. Question number 3, ये भी आप अभी आप नहीं कर सकते, because this also requires the use of logarithms. Okay, so you can skip this for now as well. Other than these two questions, other than 3 and 18, you can do the rest of them. Let's try one more. Let's try question number 16. All right. So this is an equation now. अच्छा ये तो काफी आसान लग रही है, या पढ़ सकते हैं। इक्वेशन कैसे सॉल्व करते हैं हम? प्लस माइनस लगा के आप वैल्यूज दो इक्वेशंस बन जाएंगे, उसको सॉल्व कर लेंगे, फिर वेरीफाई कर लेंगे। सो दिस वाज एन इजी वन. We have to take another one instead. Let's try this 15 instead. Let's say वो इक्वेशन दिया था, it was an inequality. वो आसान है काफी, वो आप कर लेंगे. Let's try 15 instead. Okay.
सर 17 कर लेते हैं.
ये मैं 15 करके ना एक चीज बताना चाह रहा हूँ, 17 उसके बाद देख लेते हैं फिर, अगर आपको उसमें प्रॉब्लम है तो. Okay, let's try 15, and then if you have any other questions, we can discuss them quickly. All right, let's try this. Question number 15 from the worksheet. We have to solve this inequality. Now, again, you use exactly the same process. Treat this as an equation. Instead of the inequality, you put the equation sign. 2x minus 5 modulus, that equals 3 into modulus of 2x plus 1. Okay, now you remove the modulus sign and put plus minus on any one of the two sides. 2x minus 5 equals plus minus 3 into 2x plus 1. Now this gives you two equations. One is 2x minus 5 equals 3 into 2x plus 1, and the other is 2x minus 5 and 2x minus 5 equals minus 3 into 2x plus 1. Acha, yahan pe a lot of people end up doing something weird like this. So they might do something like this. 2x minus 5 equals 3 and then plus minus x plus 1. What they would do is they would think कि अच्छा ये मॉडुलस है यहाँ पे, so मॉडुलस रिमूव किया है तो उसी जगह पे प्लस माइनस लगाना है जहाँ पे मॉडुलस रिमूव किया है. And then they would say this is either 3 plus 2x minus 2x plus 1 or 3 minus 2x minus 1. That is incorrect. You don't have to do this. You have to put plus minus on the whole thing. के ऊपर प्लस माइनस आएगा, जो भी आपके पास एक्सप्रेशन है पूरा राइट साइड के ऊपर, उस पूरे के साथ प्लस माइनस आ जाएगा. ये 3 के बाद प्लस माइनस नहीं आ रहा है यहाँ पे, 3 ऐड या सब्ट्रैक्ट नहीं होगा उसके साथ. So be careful about this. 3 मल्टीप्लाई हो रहा है, वो मल्टीप्लाई ही होगा. It's not going to be added. उसके साथ प्लस माइनस नहीं आएगा. Okay. So don't do that mistake. Let's get back to this. All right. So let's simplify these two equations now and see what we get from these. 2x minus 5 equals 6x plus 3. This gives us minus 4x equals 8 and x equals minus 2. Let's solve the other equation. 2x minus 5 equals minus 6x minus 3. And we get 8x equal to 2 and x equals 1 over 4. 2 over 8, that's 1 over 4. Right? These are two cutoff points that we're getting. What do we do now? We draw a number line and see which regions satisfy. Okay. Now, we've got minus 2 here. We've got 1 over 4 here. The three regions, we take one number to the left of minus 2. Let's take minus 3, for instance. One number between minus 2 and 1 over 4. Could be anything. Let's say 0. One number that's greater than 1 over 4. You could take 1, for instance. ये तीन numbers हमने ले लिया. In each of those three regions, अब इन numbers को हमने verify करना है इस inequality के अंदर. 2x minus 5 modulus that is greater than 3 into modulus of 2x plus 1. Okay. Let's input these values here. Minus 3 input कर लेते हैं पहले. 2 into minus 3 minus 5. That's greater than 3 into 2 into minus 3 plus 1 का modulus. Left side को simplify करें, we get minus 6 minus 5, that's minus 11 modulus, that's greater than 3 into modulus of minus 6 plus 1, that's minus 5 का modulus. On the left side, we've got 11. Right side पे 3 into minus 5 का modulus. Minus 5 का modulus क्या आएगा? 5. 3 into 5 there, 11 greater than 15. Is that correct? That is incorrect. Let's try 0 now, the number in the middle. 0 try karenge, we get 0 minus 5 modulus. That's greater than 3 into modulus of 0 plus 1. And that gives us minus 5 ka modulus, which is 5. On the right side, you got 3 into 1, which is just 3. This region is correct. Let's try the region on the right side. Modulus of 2 into 1 minus 5. That's greater than 3 into modulus of 2 into 1. हम इसमें input कर रहे हैं, remember इस inequality में input कर रहे हैं, इस वाली inequality में 3 into 2 into 1 plus 1. Let's simplify this. We get minus 3 modulus. That's greater than 3 into modulus of 3. And we have 3 greater than 9. That is, of course, incorrect. So the region in the middle is correct. The regions on the sides are incorrect. How do you write this final answer now? अब ये दरमियान वाला region है, आप इसको इस तरह से लिखते हो. You say x is greater than minus 2 and less than 1 over 4. This is how you're going to write it. जब दरमियान वाला region होता है ना, उसको एक single इस तरह से expression में लिखते हैं. ठीक है, between these two numbers. जो छोटा number होता है वो left पे लिखते हैं, बड़ा वाला number right पे लिखते हैं. So the smaller number is on the left side, the bigger number is on the right side, and you have these less than signs between these two numbers. Or दरमियान में, in the middle you've got x. All right, this is your final answer for this. Is this clear to everyone? Any problems with this? Any problem with this? No problems?
No, sir.
सर कोई रीजन सही आ जाए तो फिर सर चारों पे करना चाहिए या जब आगे तो रुक जाना चाहिए, करेक्ट आंसर आ जाएगा.
अच्छा, आप कह रहे हैं कि अगर ये रीजन आ गया है, do we need to check this region or not?
यस सर.
Sometimes what happens is you end up getting two regions which are correct. So you have to check them. However, there is a shortcut in these situations when you've got modulus sign on both sides. When you have something like this, when you have modulus sign on both sides, in these cases, you can actually reduce your working a little, and that's what I wanted to come to using this example. Let's quickly try to understand this. Whenever you've got a modulus sign on both sides, whenever you have a modulus sign on both sides of an inequality, you can actually reduce this verification working a little. How do you do that? Let me just explain that on the same page where we learned solving modulus inequalities. Just add this here. So whenever you have modulus sign on both sides of the inequality, there are only two possible cases on the number line. Number one, number two. The first possibility would be, if you've got something like this, you've got two Carter points. The first possibility is going to be that the middle region is correct and the regions on the sides are incorrect. And the second possibility is going to be that the regions on the sides are correct and the region in the middle is incorrect. When does this apply? It applies when you have modulus signs on both sides of the inequality. In this case, you have these two possible cases. Okay. Now, how does this help? Since you know there are two possibilities only, there are only two possible cases, so you can actually remember it like this. Either the middle region is correct, the regions on the sides are incorrect, right? Or the middle region is incorrect and the regions on the sides are correct. यानी middle region एक दफा या तो सही होएगा, sides वाले incorrect होंगे, या middle region गलत हो सकता है और side वाले regions सही होंगे. These are the only two possible cases. Now, how does this help? When you're doing this verification, what you can actually do is you can just verify one, you can just check one of these three regions. कोई भी एक region check कर ले, आपको पता है कि इन्हीं दोनों में से कोई possibility होनी है, या तो ये possibility है, या फिर ये possibility है. आप एक भी check कर लेंगे. For example, मैंने middle region check किया, अगर वो सही आ गया, side वाले region incorrect होंगे, वो second वाला case होगा. अगर मैंने let's say लेफ्ट वाला चेक किया और वो इनकरेक्ट आ गया, आई नो, just check any one region and you would basically figure out which one of these two cases it is. इनमें से कौन सा केस है वो आपको वहीं से पता चल जाएगा सिर्फ एक चेक करने से. लेकिन ये कब होगा सर? सिर्फ उस केस में जब आपके पास दोनों साइड्स पे मॉडुलस साइंस है. And this is actually going to be the more common case as well. When you look at past papers, ज़्यादातर questions में ऐसे ही होता है कि दोनों sides पे मॉडुलस साइन आ रहा होता है. Okay, तो उस केस में आप अपनी वर्किंग थोड़ी सी छोटी कर सकते हैं. एक चेक करेंगे आपको पता चल जाएगा, एक रीजन चेक करेंगे आपको पता चल जाएगा कौन सा केस आ रहा है. ठीक है. But the condition is don't forget that condition. When you have modulus signs on both sides of the inequality, this is the condition. जब सिर्फ एक साइड पे होगा, like we saw in other questions, in other examples, for example, we did this case. यहाँ पे क्या था? एक साइड के ऊपर था. अब इसमें देखें, you could have any possibility. इसमें हमारा ये वाला केस आ रहा था, राइट वाला करेक्ट था, लेफ्ट वाले दोनों इनकरेक्ट थे. You could also have some other cases in which we could have, you know, something like this. For instance, you could have these two regions correct and this incorrect. You could have two incorrect like this and only one correct. You could have any combination, basically. Any combination when you have modulus on only one side. But when you have modulus on two sides, there are only two possibilities. It's either this case, the first one, or this case. These are the only two possibilities. And that is when you can actually skip some of that working and just check one region, and that's going to give you the final answer directly. Is this clear to everyone? For example, in this case, if we were just to check the middle region, we would get our final answer from that directly. Any questions? No? All right, good. Now let's do one last example and then we end for today. Graphs we will discuss tomorrow, inshallah. Now you have to make sure that you attempt all of these questions now, at least the ones that I've assigned. That will make sure that your concepts are clear. If you have any questions, we could quickly discuss them tomorrow if you want. Otherwise, primarily we are going to be discussing modulus graphs tomorrow. That's going to take like 20-30 minutes, and that's with that we're going to end this topic. And in the next session after that, we will be starting binomial, and we're going to gradually pick up speed now as well, because there's a lot of syllabus. So we want to make sure that we're leaving enough time for the more difficult topics that are going to come at the end: integration, complex numbers, differential equations. So we want to speed up a little from next week onward as well, okay? But make sure that you're practicing साथ साथ तभी फायदा होएगा. Let's do one last question. then we end. Okay, yeah. So Huzaifa, you were saying 17. Are you still there?
जी sir.
Okay, let's try 17. If there are no other questions, and we end with that then. All right, this is question number 17 from the worksheet. Let's try this. It's an equation. It's going to be pretty straightforward. Let's try this. A modulus of x cube minus 14 that equals 13. Now, how do we solve equations that involve the modulus sign? How do we start? We remove the modulus sign and put plus minus on any one of the two sides. Let's say I put plus minus on the right side. Now that gives me two equations. One is x cube minus 14 equals 13, or x cube minus 14 equals minus 13. Okay. Now let's solve the first one. This gives me x cube equals 27. Now I take cube root on both sides. X equals 27 ka cube root, which is 3. This is one value of x that I'm getting. Let's try the other one. X cube minus 14, when it goes to the other side, we get 14 minus 13, which is 1. And when we take cube root, we get x equals 1. So we're getting two answers from this, x equals 1 and x equals 3. But remember, we always have to verify our answers. We can check them. आप यहाँ पे input करके देख लें. You'll figure out both of them satisfy this equation. So both of them are correct. X equals 3 or x equals 1. These are the two solutions that we've got for this equation. Okay, question number 4. We have to solve this inequality. 2 minus 3x is less than modulus of x minus 3. How do we start? We treat this as an equation. Inequality की जगह पे we put an equation sign. 2 minus 3x equals modulus of x minus 3. Now, how do we solve this equation? We remove the modulus sign and put plus minus. This gives us two equations. One is 2 minus 3x equals x minus 3. And the other is 2 minus 3x equals minus into x minus 3. Okay? Let's solve these two equations now. We get minus 4x equals minus 3 minus 2, which is minus 5. And x equals 5 over 4. From the other equation, we're getting 2 minus 3x equals minus x plus 3. We get minus 2x equals 1, and x equals minus 1 over 2. Yeah, I think that's what we're getting. Minus 1 over 2. Okay? These are two results that we're getting, but this is not our final answer yet. We were actually solving an inequality, not an equation. So now we draw a number line. We draw a number line and we mark those 2 points here. One is minus 1 over 2 and the other is 5 over 4. Now, these 2 points divide our number line into 3 different regions. Okay, so we've got 3 different regions here. One towards the left of minus 1 over 2. Minus 1 over 2 ke left side pe, we could take minus 1, for instance. Between minus 1 over 2 and 5 over 4, we could take 0. And greater than 5 over 4, 5 over 4 is 1.25. So 1.25 is a bada number. We could take 2, for instance. All right. Now we've got to verify these 3 numbers. Check these 3 numbers in that original inequality and see which of the 3 regions satisfy. Now you see, the modulus sign is only on one side. It's going to be necessary to check all 3 regions. That is going to be important. All right. Let's check the first region. Minus 1 check karte hain. 2 minus 3 into minus 1. That is less than modulus of minus 1 minus 3. And this gives us 5 on the left side. On the right side, we've got modulus of minus 4. So we have 5 less than 4. That is incorrect. So this region is not correct. Let's check the region in the middle. We've got 0 in the middle. So that's 2 minus 0 less than modulus of 0 minus 3. That gives us 2 less than modulus of minus 3. And we're getting 2 less than 3. Is that correct? Yes, this is correct. So the middle region is correct. Left wala incorrect tha, but the middle one is correct. Let's check the one on the right. Let's input 2 in that inequality. We have 2 minus 3 into 2. That is less than modulus of 2 minus 3. All right. Now on the left side, you've got minus 4. Minus 4 is less than minus 1 modulus, and we're getting minus 4 less than 1. This is also correct. So you see, this region is correct, and this region is also correct. We have two regions which are correct. What is our final answer now? How do we write our final answer? Any idea? आप देखें diagram पे देखें, number line पे देखें, कौन सा region correct है? How would you describe this region? It's basically anything that's towards the right side of minus 1 over 2. Minus 1 over 2 के right side पे जो भी आ रहा है, that is correct. So the final answer therefore is going to be x greater than minus 1 over 2. That is your final answer, because anything that you've got towards the right of minus 1 over 2 is correct. So this is your final answer. All right. Now, just to answer Josefa's question quickly, he's saying, can we have an inequality that has an greater than or equal to or less than or equal to sign? So for example, could we have something like this, 2 minus 3x less than or equal to modulus of x minus 3? Yes, that's possible, but nothing changes in this whole process. If you had an inequality sign here, all you would do is you would say the final answer is x greater than or equal to minus 1 over 2. So जो भी आपका आंसर आएगा एंड के ऊपर वहां पे भी आपने इक्वल टू का साइन डाल देना साथ उसके. That's the only thing that's going to change if you get something like this. Greater than or equal to आ जाए, less than or equal to आ जाए, आपने फाइनल आंसर में सिर्फ क्या करना है, उसमें भी इक्वालिटी का साइन डाल देना है. Everything else is going to remain exactly the same. ज्यादातर इसी तरह से आते हैं. इनफैक्ट I haven't seen any example जहां पे उसने less than or equal to यूज किया, but अगर कर ले, nothing changes, everything is exactly the same. बस यहाँ पे भी आप इक्वालिटी का साइन डाल दोगे. All right, I hope that makes sense. Any other questions?
फिर अगर वो इक्वल हो रहा हो तो वो फिर उस रीजन के अंदर वो चीज भी आती है.
वो रीजन में नहीं आएगा, लेकिन क्योंकि उसने ये जो पॉइंट्स है ना, ये रिप्रेजेंट कर रहे हैं इक्वालिटी वाला केस. जब उसने इक्वालिटी वाला केस पूछा हुआ है, बस आप अपने फाइनल आंसर में इक्वल टू का साइन भी डाल देंगे, तो वो ऑटोमेटिकली वो हैंडल हो जाएगा खुद से. -1 over 2 और 5 over 4 कैसे आए थे हमारे पास पॉइंट्स? ये आए थे जो हमने उनको इक्वेट किया था, उससे आए थे. राइट, बस इसी को यूज कर लेंगे यहाँ पर.